Okay, so it is day 3, and it's going to start in a minute, and we will do some live coding, and hopefully we will solve it quickly. Today I planned ahead and already started with a bunch of imports that I might want to use, annotations, all my favorite types, um, iter tools, which I might use, default dict and counter, which I might use, and who knows, maybe I will use none of them, but uh, maybe I will use some of them, and let's see, hopefully the problem is not too hard today. Although the day 3 is when, I think when they start making it hard in past years, so maybe it will start being hard. All right, let's go. Uh-oh, website problems. With the toboggan login problems result, toboggan login, that's clever. Set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering. The area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow in exact integer coordinates in a grid. You make a map of the open squares and trees you can see. For example, this. Those aren't the only trees, though. Due to something you read about once involving arboreal genetics and biome stability, same problem repeats to the right many times. You start on an open square in the top left corner and need to reach the bottom below the bottommost row in your map. The toboggan can only follow a few specific slopes. You opt for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope. Right 3, down 1. Locations you check in the above example are marked here with O, where there's an open square, and X where there's a tree. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Okay, so let's say that slope is that thing right there. And now let's say, and of course I did not, and so let's say we'll do a point which is a name tuple, and this will just be the dumbest possible point, which will be x as an int and y as an int, and uh, and let's say we're going to find the trees from raw, which is a string, and is going to return a list of points. And what do I want to do is I want to say return point xy for let's say y row in enumerate raw dot split on new lines, and then for xc in enumerate row if c equals pound. Okay, so let's run this and try to find the trees for that slope. And I think I did it in all caps. And so I said x2, y0, x3, y0, x0, y1. Okay, so that looks pretty reasonable. And now let's say count trees and go back and say slope of right 3 and down 1. So we have to guess a little bit as to what. So let's say trees is going to be a list of points. Right int equals 3 and down int equals 1. And we have to guess about what they're going to do in part 2. So my guess is that maybe it'll change right and down and want us to count differently. And what do I want to, uh, let's say, I want to do the width, which is going to be an int, which is going to be, because we repeat every, like, basically it repeats, right? And I guess we need to do a height int as well. And so what I want to do is I want to say for y in range height, x, actually range 0 height, and down. So we want to do it that way. And so what is x going to be? And let's start with x equals 0. Oh, well, we'll just do this. X equals, no, we'll start with x equals 0. So x equals x plus right, and then we're going to need to mod it by the width because we want it to repeat each time. And let's just say numTrees equals 0. If x, y in trees, numTrees plus equals 1. And now let's return numTrees. So let's say trees equals, find trees for the slope, and width equals len of, this is sort of a mess. Say lines equals slope. So let me do, I'm going to change this quite a bit actually, just to make it cleaner, because I prefer it being cleaner. And so I'm going to make a something to actually represent the slope, which is a name tuple, and it's going to have trees, which is a list of points, and it's going to have a width, which is an int, and it's going to have a height, which is an int. And then I'm going to do the same thing that I did yesterday, which is a static method. And what will I call it? I'll call it parse raw, which is a string, and it's going to return me a slope. And so I'm going to say trees, or let's say lines equals raw dot split on new lines, and then trees equals point xy for y row in enumerate lines, for xc in enumerate row if c equals that, which is fine. Width equals len of lines 0, and height equals len of lines. And now I can return the slope with those trees and that width and that height. So that will make my life easier. And then let's say slope equals slope dot parse raw. That's good. And now I want to count the trees, and now I'll just have a slope, which is a slope. NumTrees equals 0. This will be slope dot height down, slope dot width, and slope dot trees. Now it's much cleaner. And now I want to assert that, call this slope, assert that count trees slope equals and 7. So let's see if that actually works. Except I want to run it. Assertion error. Okay, so slope and count trees slope is 3. Okay, so I did not get it right. So let's just print x, y, and make sure that 3, 6, 9. So the width is 1, 2, 3, 4, 5, 6, 7, 8. So it should start at 0, 0. It should start at 0, 0. So why did it start at 0, 3? Because I screwed something up. This should go maybe after that. Okay, so now let's run it, and the assertion passes. And let's just print x, y to be safe. 0, 0, 3, 1, 6, 9, it wraps around to, okay, so it seems reasonable. So let us get my puzzle input. And that looks like it might have I'm just going to put a row.stripped here to be safe, because it looks like there might be blank spaces at the end. So let's do day3.text. Actually, no, that seems fine. But okay, so now let's go back to my code and say with open inputs day3.text as f raw equals f.read, slope equals slope dot parse raw, and then print count trees slope. Okay, so let us run it, and it says 195. So let's try that and see if it's right or if it's wrong. That's the right answer. Time to check the rest of the slopes. You need to minimize probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if for each of the following slopes you start at the top of the corner map all the way to the bottom. Blah, blah, blah. Those slopes would find 2, 7 when multiplied together. Okay, so my guess was a good one. And okay, so for so product equals 1 for write down in let's say 1, 1, 3, 1, or no, let's do this differently, which is count or let's call it trees product of slope, which is a slope, and then yes, that's funny. Slopes, which is, I'll call it a list of points, even though it's not really points, but it is, and it's going to give me an int. And then what I will do is I'll say product equals 1 for write down in slopes. Product times equals count trees slope right equals right, down equals down. And then return product. And now let's say slopes equals, and in their example, there's 1, 1 and 3, 1. And I'm really overloading my point class because these are not points, these are slopes. 1, 2. And now I want to assert that trees product slope and slopes equals 336. So let us see if that's right. You know, part of me worries that this thing with the down is not going to work, but it seems to have. So that means that I have the same, so print trees product, and then lowercase slope is our input, but then we still use the same uppercase slopes. So let us run that, and it's giving me a big number. So let's put that in and see if it's right. That is the right answer. You're 1 gold star closer to saving your vacation. You have completed day 3. You can share this victory or return to your advent calendar. So let's go back and just look at the code very quickly, because it's a little bit messier than it could be, but it's all right. So I defined this point class. I could have there was really no need to do that. Like, what I really, so here's what I should have done. This would have made much more sense, is that instead of using a name tuple for that, like that was overkill. I should have just used a tuple. Okay, and obviously I didn't need either of these. And so what I should have done is I should have just said point is going to be a tuple int, because I didn't actually dot into it for x and y or anything. And now I feel better about it because they're not called x and y. So now we have a slope, which is trees, and a width and a height, and this static method. Now I don't even need to call it point xy. It's just xy because it's a bare tuple, which is fine. So what did I do? I said take this raw text and split it on new lines, so I get each line as one. And now I'm going to enumerate those lines, and so that gives me each line along with like 0 and line 0, 1 and line 1. And then for each of those rows, I'm going to enumerate that again and get, you know, x equals 0, the character at x equals 0, x equals 1, the character at x equals 1, and then I only want to keep the ones where the character is actually a pound, because that means tree. So if I do that, then I and so like what I really should have done, and this should have been a set as well, like so what I should have done is that trees was a set of points, and then because you know it would have run much faster because checking for set membership is faster. And okay, so that's good. And so I return this slope object, which has the trees and also the width and the height. And now in order to count trees, you know, I use a slope and I use right and down, which is a different kind of slope, so that's confusing. Number of trees is 0, start at x equals 0, and start at y equals 0. And now, you know, the down says how far do I go down each step, and obviously I want to stop when I get to the height. And I just check, is this a tree? If so, you know, add 1 to trees. And then what I want to do is when I increment x by right, and then because we've said that, you know, this pattern repeats, I just mod it by the slope width, and that does the right thing. So, and then for part 2, I basically just said, here's, you know, here's all these different directional slopes that I want to check, and I'll just use my part one for each of them and take their product. And so now with those changes, let's make sure that it runs and gives the same answer, and it does. And so that means that we're in pretty good shape. Cool. So that was, um, you know, I started off not modeling it the way that I wanted to model it. And then I found that I actually did want to model it the way I wanted to model it, so I should have just modeled it with this name tuples and static, constructor method in the first place. So lesson learned: follow your instincts, and that's it. Yeah. So I'll push this to GitHub, and I will see you tomorrow.